Okay friends, after completing the theory part in steam nozzle, now we have to go for the numerical parts. A convergent divergent nozzle is required to discharge 360 kg per hour of steam. The nozzle is supplied with a steam of 10 bar and 0.97 dry and discharges against a back pressure of 0.5 bar. Neglecting the effect of a friction and using a HS chart or a Moliere diagram, find the throat and exit diameters, assume a condition for maximum discharge. Note, for wet steam n equal to 1.113. So this is a statement for the given steam nozzle problem. So now we have to consider convergent divergent nozzle, which is shown in a figure. D1 is the diameter at a convergent section, D2 is a diameter at throat section, D3 is a diameter at divergent section. P1, P2, P3 are the pressures at convergent, throat and divergent section respectively. Mass flow rate is given, that is 360 kg per hour, that will be converted to kg per second. 360 divided by 60 into 60, that is 0.1 kg per second. P1 is given, that is 10 bar. X1 is the dryness fraction for that particular pressure, that is 0.97. P3 is the back pressure after discharge. It means that will be indicating divergent section pressure, that is 0.5 bar. Then we have to find out diameter D2, D3 and P2, D1. We know that critical pressure ratio or condition for maximum discharge, P2 by P1 equal to 2 by n plus 1 raised to n minus 1 divided by n. For wet steam, n equal to 1.113. Therefore, P2 by P1 we are getting here P2 by P1 equal to 2 divided by 1.113 plus 1 raised to 0.113 divided by 1.113 into 10, that is P2 equal to 0.582 bar, 582 bar. Therefore, from HS chart or Moliere diagram, at pressure P1 10 bar and dryness fraction 0.97, we getting enthalpy of 2700 kilojoule per kg. In a Moliere chart or a HS diagram, we have to go through the pressure lines and dryness fraction lines. For pressure P1 line 10 bar and x1 equal to 0.97. So these are for taking these two parameters, we are finding a point where these two lines are intersecting. So exactly that point we are drawing the horizontal line where we are getting the enthalpy of 2700 kilojoule per kg. So that is point 1. Now at P2 5.82 bar, we have to finding the enthalpy. So after getting a point 1 in a Moliere diagram, so that has to be exactly vertically, we have to draw one exact vertical line where it will be cutting the pressure line of 5.82 bar. So that is that intersecting line, that is point 2, that through that point 2 we have to draw horizontal line. So we are getting enthalpy, that is S2 2610 kilojoule per kg. So that particular point we have to also getting dryness fraction of x2 0.93 and specific volume of Vg2 equal to 0.35 meter cube per kg. At P3 equal to 0.5 bar, we are once again go through that vertical line, that we have to draw the vertical line continually from point 2 where the point 3 is getting. It means that will be cutting a 0.5 bar line. Through that point 3 we have to draw a horizontal line through which we are getting enthalpy, that is S3 equal to 2240 kilojoule per kg. Therefore x3 equal to 0.82 bar, 0.82 and specific volume equal to Vg3 equal to 3.2 meter cube per kg. Now we have to find out V2 and V3. V2 equal to 44.72 square root of delta H, that is equal to 44.72 square root of H1 minus S2. Therefore V2 equal to 44.72 square root of 2700 minus 2610 equal to 424.25 meter per second. V3 equal to 44.72 square root of delta H, 44.72 square root of H1 minus H3. V3 equal to 44.72, that is square root of 2700 minus 2240, that gives the 960 meter per second. Now we have to find out diameter. For that we need a continuity equation, m equal to a2 v2 divided by vs2, that is equal to a2 v2 divided by x2 Vg2. Therefore A2 equal to m into x2 Vg2 divided by V2. Therefore we are getting area A2 equal to 7.67 into 10 to minus 5 meter square. Therefore area of the throat section, that will be A2 equal to pi by 4 d2 square. Therefore d2 equal to 9.88 into 10 to minus 3 meter. Like that we have to find out diameter for divergent section.